Good evening, dear student. Very happy to see you, everyone. See, today I am going to discuss that is rules for the determination of oxidation. Determination of oxidation number of or oxidation state. See, rules for the determination of oxidation number or oxidation state. Already we discussed last class, that is the oxidation number of an element in the free or elementary state or any of its allotropy the oxidation number of an element in the free or elementary state or in any one of its allotropic forms is always zero. Example, oxidation number of helium, hydrogen, oxygen in O2 or O3, iron in iron, like we can say iron in Fe and carbon in diamond are zero. Carbon in diamond are zero. That is, we can say the oxidation number of an element in the free or elementary state or in any of its allotropic forms is always zero. Okay. Then next, if covalent, second rule is if covalent bond is between two different atoms, then electrons are counted towards more electronegative atom. Thus, oxidation number of more electronegative atom is negative and oxidation number of less electronegative atom is positive. That is second point. Once again I am repeating. If covalent bond is between two different atoms, what is the covalent bond? Covalent bond is nothing but sharing of electrons or mutual bond. It is known as covalent bond, sharing of two atoms. If covalent bond is between two different atoms, then electrons are counted towards more electronegative atom. Thus, oxidation number of more electronegative atom is negative and oxidation number of less electronegative atom is positive. Then next, rule number 3. If there is a coordinate bond between two atoms, oxidation number of donor atom will be +2 and of acceptor atom will be -2. Like we can say substance A plus substance B gives rest substance A 2 plus substance B -2. Once again I am repeating rule number 3. If there is a coordinate bond between two atoms, oxidation number of donor atom will be +2 and acceptor atom will be -2. Okay, like we can say, example we can say magnesium atom +2, Mg +2, oxygen is -2. Then magnesium is ready to give 2 electrons and oxygen is ready to take 2 electrons. That is why MgO it will form. Then next, rule number 4. The oxidation number of all the atoms of different elements in their respective elementary states is taken to be 0. For example, in nitrogen is two atoms, same kind of atoms. That is, nitrogen is two atoms, like N bond, nitrogen and nitrogen, in between it is sharing electrons. And chlorine, Cl2. See, nitrogen is N2 molecule, chlorine molecule, then H2 molecule, phosphorus, like we can say P4. Sulfur is rhombic sulfur, that is S8. Okay. Then oxygen O2, Br2, bromine. Then sodium Na, iron Fe, silver Ag, etc. The oxidation number of each atom is 0. The oxidation number of each atom is 0. See, once again I am repeating fourth rule, because why I am discussing here, already I sent PDF. Okay, whoever there, one or two students, I sent already PDF. Then I am discussing here. If you need PDF, kindly send me your phone number, then I will forward. See, the oxidation number of all the atoms, different elements in their respective elementary states, is taken to be 0. For example, in nitrogen, nitrogen is one atom of nitrogen, another atom of same kind of nitrogen in between nitrogen, that is oxidation number is 0. Why? Because one nitrogen atom is 3 electrons, and another nitrogen also it is required 3 electrons, it is sharing. Then chlorine also same manner. Chlorine atomic number is 17, hydrogen atomic number is 1, phosphorus is 15. Then sulfur, even oxygen and bromine, sodium, iron, silver, these all, the oxidation number of each atom is 0. Then next, fifth point I am going to discuss, that is fifth point. The oxidation number of a monoatomic ion is the same as the charge on it. For example, oxidation number of sodium Na plus, the charge on it. For example, oxidation number of sodium Na plus and Mg2 plus and aluminum 3 plus ions are, like we can say, plus 1, plus 2, plus 3. Why? Because sodium atomic number is 11. Sodium guy, he is ready to give one electron. That is why Na plus. Magnesium atomic number is 12. Then if he is losing 2 electrons, then he will get nearest noble gas configuration of neon. Okay. Then next, aluminum atomic number is 13. Aluminum is, if it is losing 3 electrons, then he will get nearest noble gas configuration, that is neon. That is why aluminum is ready to give 3 electrons. That is why we can show that aluminum oxidation is plus 3. That means oxidation means plus 3 respectively, while those of chlorine Cl minus, sulfide S2 minus, and nitrogen 3 minus ions are minus 1, minus 2, minus 3 respectively. Okay. I am going to discuss sixth point. The oxidation number of hydrogen is plus 1 when combined with non-metal, and is minus 1 when combined with active metals. Active metals called metal hydride, such as like lithium hydride, potassium hydride, magnesium hydride, calcium hydride, etc. See, I am going to discuss this point. The oxidation number of hydrogen is plus 1. Hydrogen always, it is proton, it is ready to give 1 electron. Why? Because he is ready to like we can say everywhere available this element, which is hydrogen element, everywhere is available. That is why always be positive. That B positive symbol is hydrogen. He is ready to attract or ready to give 1 electron. Okay. That is why it will show our human being also, we should show nature is always be positive, whatever may be. Even any drastic conditions also, very bad conditions also, we should be positive. Then only our life we can lead. Okay. I will believe that, because hydrogen, this is just I want to tell that be positive nature. That is why H plus is always plus 1 charge. Okay. Then next, the oxidation number of hydrogen is plus 1 when combined with non-metals, and is minus 1. When combined with non-metals, it is showing -1 charge. Okay, that is when combined with the active metals called metal hydride, like such as lithium hydride. Why? Because lithium one electron giving and hydrogen also one electron sharing, both sharing, it is going to form lithium hydride, LiH, comma, then next potassium hydride. Potassium is ready to give one electron, then hydrogen also sharing one electron, then it will form bond KH. Then another one, magnesium hydride. Say dear, think once, magnesium hydride formula is it MgH or MgH2? Because it is not MgH. Magnesium hydride, it is not MgH. You have to write always MgH2. Why? Because magnesium is 2 electrons ready to give electrons, and hydrogen is 2 atoms required that 2 electrons taking purpose, sharing purpose. That is why formula is MgH2, magnesium hydride. Then next, another one example is calcium hydride. Even calcium hydride also same, calcium valence is +2. That is why 2 atoms of hydrogens are required for 2 electrons sharing. That is why formula is CaH2. This is, we can tell this for point is like this. Okay, I think it's clear. Then next, another point, seventh point, the oxidation number of oxygen is -2. You know very well, the oxidation number of oxygen is -2. Why? Because oxygen atomic number is 8. If he is gaining 2 electrons, then he will complete nearest noble gas configuration, that is neon. Okay, then in most of its compounds, except in peroxides such as H2O2 or barium oxide, BaO2, etc. See, here exception is there. We have to discuss that exception. Mister, kindly join, don't leave. If you are there, that is why I am continuing. See, exception in the compound OF2, oxygen difluoride, where the oxidation number of oxygen is +2. This is due to the fact that fluorine, being the most electronegative element known, always has an oxidation number of -1. Next, another point, in compounds formed by union of metals with non-metals, the metal atoms will have positive oxidation numbers and the non-metals will have negative oxidation numbers. Then next, another point, in compounds formed by the union of different elements, the more electronegative atom will have negative oxidation number, whereas the less electronegative atom will have positive oxidation number. The next point, for neutral molecule, the sum of the oxidation numbers of all the atoms is equal to 0. The next, another point, transition metals exhibit a large number of oxidation states due to involvement of n-1 d electron besides ns electrons. The next point, oxidation number of a metal in carbonyl complex is always 0. Example, nickel has 0 oxidation state. That is, we can say that nickel hexacobalt, nickel tetracobalt. The next point, those compounds which have only carbon, hydrogen, oxygen, the oxidation number of carbon can be calculated by following formula. Then how we can calculate that? Oxidation number of carbon is equal to n naught multiply 2 minus nh upon nc. See, once again I am repeating that oxidation number of carbon is equal to n naught multiply 2 minus nh upon nc, where n naught is the number of oxygen atom, nh is the number of hydrogen atom, and nc is the number of carbon atom. For example, methanol formula is CH3OH. NH is equal to 4, NC is equal to 1, N naught is equal to 1. Oxidation number of carbon is equal to, here methanol formula is CH3OH. How many number of carbons? Only one. Okay. Then next N naught NH is equal to 4. Why? Because 4 hydrogens there. Then NC is equal to 1. N naught is equal to 1. Then oxidation number of carbon, that is equal to 1 multiply with 2 minus 4 upon 1 is equal to minus 2. That means oxidation number of methanol in the carbon is value is minus 2. Then formic acid, HCOH, NH is equal to, then N0 is equal to, NC is equal to 1. Then oxidation number of carbon is equal to 2 multiply 2 minus 2 upon 1. That is the oxidation number of carbon is plus 2. Then oxidation state as a periodic property. Oxidation state of an atom depends upon the electronic configuration of that atom and hence it is a periodic property. Then next, alkali metals shows plus 1 oxidation state. Alkaline earth metals show plus 2 oxidation state. See, once again I am repeating that oxidation state as a periodic property. Oxidation state of an atom depends upon the electronic configuration of that atom and hence it is a periodic property. Alkali metals shows plus 1 oxidation state. Alkali metals, it will show plus 1 state oxidation, plus 2 or plus 1 oxidation state. Alkaline earth metals shows plus 2 oxidation state. The maximum normal oxidation state shown by third A group elements is plus 3. These elements also show plus 2 plus 1 oxidation states. Elements of fourth A group show their maximum and minimum oxidation states plus 4 and plus 4 and minus 4 respectively. Non-metals show number of oxidation states. The relation between maximum and minimum oxidation states for non-metals is maximum. Oxidation state, minimum oxidation state is equal to 8. For example, sulfur has maximum oxidation number plus 6 as being in 6th A group elements. Fractional oxidation states. See, what is the next topic is fractional oxidation states. Many elements show fractional oxidation states. For example, oxidation state of oxygen is in superoxides of alkali metals KO2, potassium dioxide, sulfur dioxide, rubidium dioxide RbO2 is minus 1 by 2. For example, in Fe3O4, that is iron oxide, iron shows its oxidation state as 8 by 3, 8 upon 3, as it is mixed oxide and can be written as iron 11. Iron 2, iron Fe2, like Fe2 is Fe plus 3, then oxygen 4. The next, exceptional cases of evolution of oxidation number. See, exceptional cases of evolution of oxidation number. What are the exceptional cases? We have to discuss. That is, exceptional cases of oxidation states or exceptional cases of evolution of oxidation number. That is, the rules described earlier are usually helpful in the determination of the oxidation number of a specific atom in simple molecules, but these rules fail in the following case. In these cases, the oxidation number are evaluated using the concepts of chemical bonding involved. Type 1, in molecules containing peroxide linkage in addition to element oxygen bonds. Oxidation number of sulfur in H2SO3, H2SO5, that is per monosulfuric acid or Corrosic acid, that is another name is Corrosic acid, H2SO5. By usual method is H2SO5. Hydrogen is 2. 2 in multiply 1 plus x plus 5 multiply minus 2 is equal to 0. That means x is equal to minus 8. But this cannot be true as maximum oxidation number of our sulfur cannot exceed plus 6. Since sulfur has only 6 electrons in its valency cell, this exceptional value is due to the fact that two oxygen atoms in H2SO5 shows peroxide linkage as shown below. How we can show that? Hydrogen oxygen sulfur double bond oxygen then oxygen oxygen hydrogen, that is peroxide linkage is there. Because of that it will show. Therefore the evolution of oxidation number of sulfur should be made as, we can show that 2 multiply plus 1 plus x plus 3 multiply minus 2 plus 2 multiply minus 1. Like we can say, for hydrogen 2 plus x minus 6, for sulfur minus 2 is equal to 0, x plus 6, like x is equal plus 6. Then oxidation number of sulfur in H2S2O8. H2S2O8, what is the name of H2S2O8? That is peroxydisulfuric acid or Marshall's acid. Marshall's acid. See, Marshall's acid formula is H2S2O8. H2S2O8 is Marshall's formula. Marshall's formula H2S2O8. See, previous we given, that is Corrosive acid. Corrosive acid formula is H2SO5. H2SO5 is corrosive acid. But Marshall's acid formula is H2S2O8. Okay. Then by usual method H2S2O8, 1 multiply 2 plus 2x plus 8 minus 2 is equal 0. Here 2x is equal to plus 16 minus 2, that is equal 14, or x plus 7 plus 7. Similar to corrosive acid, Marshall's acid also has a peroxide linkage, so that sulfur shows plus 6 oxidation state. Okay. Therefore the evolution of oxidation state of sulfur should be made as follows. Like we can show, 2 multiply plus 1 for hydrogen plus 2 multiply x for sulfur plus 6 multiply minus 2 for oxygen plus 2 multiply minus 1 for oxygen, that is equal 0. That is why in this case x is equal to plus 6. Then oxidation number of chromium in, like we can say Cr, chromium pentoxide, blue perchromate. Blue perchromate formula is CrO5. CrO5 is blue perchromate. Then this one already we sent PDF once you observe. Then we are going to discuss next topic, that is I will send in description even practice questions also. Practice questions also I will send in description. Kindly fill that and kindly revert that answers. Okay. Then can we take more? Yes, we have to take. See, oxidation number of chromium in CrO5 blue perchromate. By usual method, chromium pentoxide or x minus 10 is equal to 0. X plus, that is equal, x is equal plus 10. This cannot be true as maximum oxidation number of chromium cannot be more than plus 6. Since chromium has only 5 electrons in 3d orbitals and 1 electron in 4s orbital, this exceptional value is due to the fact that 4 oxygen atoms in chromium pentoxide are in peroxide linkage. The chemical structure of chromium pentoxide is peroxide linkage, that is chromium double bond O, then cross side like 4 side 4 oxygen atoms, then peroxide linkage. Therefore the evolution of oxidation number of chromium should be made as follows. That is x plus 1 multiply minus 2 plus 4 minus 1 is equal 0. Then x minus 2 minus 4 is equal 0. Then x is equal plus 6. Then next type 2, in molecules containing covalent and coordinate bonds, following rules are used for evaluating the oxidation number of atoms. That is type 2 questions, how they are going to. For each covalent bond between dissimilar atoms, the less electronegative element is assigned the oxidation number of +1, while the atom of the more electronegative element is assigned the oxidation number of -1. In case of coordinate covalent bond between similar or dissimilar atoms, but the donor atom is less electronegative than the acceptor atom, an oxidation number of +2 is assigned to the donor atom and an oxidation number of -2 is assigned to the acceptor atom. Then conversely, if the donor atom is more electronegative than the acceptor atom, the contribution of the coordination bond is neglected. Example are as follows, like oxidation number of carbon in HC, hydrogen cyanide, triple bond nitrogen, and HN triple bond C. The evaluation of oxidation number of carbon cannot be made directly by usual rules, since no standard rules exist for oxidation number of nitrogen and carbon. The next, in such cases, evaluation of oxidation number should be made using indirect concept or by the original concepts of chemical bonding. Then oxidation number of carbon in hydrogen, nitrogen, triple bond carbon, the contribution of coordination bond is neglected, since the bond is directed from a more electronegative nitrogen atom donor to a less electronegative carbon atom acceptor. Therefore, the oxidation number of nitrogen in HN triple bonds carbon remains. Therefore, the oxidation number of nitrogen in HN triple bond C remains -3 as it has 3 covalent bonds. Then oxidation number of carbon in HC triple bond nitrogen in hydrogen cyanide triple bond nitrogen. Nitrogen is more electronegative than carbon. Each bond gives an oxidation number of -1 to nitrogen. There are 3 covalent bonds. The oxidation number of nitrogen is hydrogen cyanide triple bond nitrogen is takes as an -3. Now hydrogen cyanide triple bond N +1 plus X and -3 is equal 0. X is equal plus or +2. Then type 3 questions. Type 3 questions. In a molecule containing 2 or more atoms of the same or different elements in different oxidation states, that is oxidation number of sulfur in Na2H2O3. By usual method, Na2H2O3, that is 2 multiply +1 +2 multiply X plus 3 -2 is equal 0. X is equal to. But this is unacceptable as the 2 sulfur atoms in Na2H2O3 cannot have the same oxidation number, because on treatment with dilute H2SO4, one sulfur atom is precipitated while the other is oxidized to sulfur dioxide. Then Na2H2O3 plus H2SO4 sulfuric acid gives us sodium sulfate Na2SO4 plus sulfur dioxide plus sulfur plus H2O. In this case, the oxidation number of sulfur is evaluated from concepts of chemical bonding. The chemical structure of Na2H2O3 is, like we can show, sodium Na plus oxygen minus bond sulfur, then sulfur above arrow mark sulfur, and side bond O minus Na plus, and down double bond oxygen. That is the structure of Na2H2O3. Due to the presence of a coordinate bond between 2 sulfur atoms, the acceptor sulfur atom has the oxidation number of -2, whereas the other atom gets oxidation number of +2. Then 2 multiply +1 plus 3 multiply -2 plus X multiply 1 plus 1 multiply -2 is equal 0. Okay, this is the like oxidation number of sulfur in Na2H2O3. Same manner few more there. Then next topic is balancing of oxidation reduction reactions. That is we need to discuss. Actually I have to explain on the notebook. Next topic I will explain. I will bring that those instruments. Then I will continue next class. Thank you, Mr.